Hey everyone, welcome to your Play Pause It for the week. It is so different this week because it was exam week for us. We're having it on Friday, and you can see that the screen is different than it's ever been. We're going to be going over the Desmos activity that I assigned you guys this week. I know that it was a little bit different. We don't usually do them outside of class, so I wanted to make sure we had some dedicated time to look at it together, and I thought a Play Pause It would be a great time to do that. So when you guys logged in, this would have been the first screen that you saw. It says put a point on the line. And the great thing about Desmos is the interactivity of it. So let's say I'm like, oh, I don't really know how to do this. I'm just going to try a point. So you put a point in. And you click share with class, and it puts the point on the grid for you. And you can see, hey, wait a minute. It told me to put the point on the line. So see, that point is not on that line. The line's up here. So maybe that will sort of help jog your memory on how to plot points. Oh, I went over one. How can I get it to that line? I could go all the way up to 11. So I'm going to edit my response, add an 11 on the Y value there, and there we go. It is now on the line. There's going to be a ton of different responses for this because this line is pretty long, at least the line that's in the viewing window. It most likely does go on forever, although we don't know for sure. There's no arrows, but likely that's what happened. So you could have a variety of answers here as long as that orange dot is on the line. So let's look at some of your responses. And I did anonymize these so you're not going to actually see any of your names. So check it out. Here's all of your responses. I can see, I'm going to do an overlay, which is really cool. I'm going to see everybody's answers at the same time. Look at that. So you can see the majority of the class here has the dot on the line in various places. And then we have some who the point stayed off the line. Maybe you just weren't sure how to proceed or you didn't know how to edit it. It's kind of what I wanted to show you as well, and how to, once you submitted your response, all you have to do here is click edit my response and you can change this coordinate point. Let's say -1, 7. And click share with class, and there it is. There's that coordinate point. So the first thing we want to do is just kind of review plotting points and make sure we could get it on the line. Our second screen here wanted you to find a solution to this equation. Type an ordered pair that is the solution. So a solution to an equation is where you have some x value and you get a y value out, or vice versa. So you guys could pick any x value and input, put it into the equation, and get out some y value. A lot of people chose 0 for x because it's easy, right? 0 is an easy number to work with when you're dealing with this equation. When you plug 0 in for y, you get 2, right? Because 0 plus 2 is 2. So there's that coordinate point, and I'm going to share it with the class. And as you were doing it, you would have seen other students' responses down here. Because I'm the only student now, sadly, I'm not going to see those responses, but I'm going to show you your responses. So you can see a ton of people chose 0, 2, just like I thought they would. All these people, all these anonymous mathematicians, that's you guys. Some, a smaller subset, chose 1, 3. You can see the different coordinate points. There's going to be, again, a variety of possible answers. It just depends what x value you plugged in to get out a y value. So here, that's an equation of a line. And it wanted a coordinate point, an x value and a y value. So here is that ordered pair that you found. They went ahead and plotted it on a line for you together with the equation. So let me do another overlay. So our first screen, we just picked a point. The second one, we found it algebraically. And look, you guys, those points got a lot closer to that line. There's only a few now that are sort of hanging out off the line. But you can see graphically, when we did this one, and you guys picked a point, it lied on the line. And then numerically or algebraically, when you picked a value, it laid on the line. And I loved a lot of your responses for how do you know. I actually snipped those here in our snapshots. Let me show you. These are some great sort of thinking through the problem here because you plugged it into the equation. I think my ordered pair is correct because it falls on the line and satisfies the equation. So you guys were working through that mathematically beautifully. All right, our next slide says, what does a solution mean? What does it mean when we take some x value and put it into an equation? So here's an example. If I say 2 comma 5 is a solution to the equation, what does that mean? And let's look at what you guys said it means. For a point to be a solution, it has to fall on the line. I love that. So this person was thinking graphically. Even though this example didn't give you any graphs, this person's response was graphically. It has to fall on the line. Let's look down a little further. Here we go. If a point is the solution to a linear equation, then the point will lie on the line graphically. But also, to check it, you can plug it into the equation. So we also have it algebraically. So if we were to plug, okay, let me go back to your screen. We could check this work by plugging 2 in for x and c and 5 in for y and see if it's true or false. Let's do that out this way. So we get 4 plus 3, 5 equals 7. Does 5 equal 7? No. So 2 comma 5 is not a solution because it doesn't work. It doesn't make sense mathematically. So it is not a solution. Also, 2 comma 5 should not be on the line. So there's kind of two ways to tell if something is a solution. It lives on the line and it works in the equation. So let's look at these two lines. Is there an ordered pair that is a solution to both of the lines? And we talked about this a lot in class. So I'm guessing a ton of you got this correct. Let's look at the summary for slide 5, the teacher zone for slide 5. And 112 of you said yes. A few of you did say no. But hopefully now after watching this, that will help those people who said no understand a little bit better. Let's look at some of your explanations. Yes, there's a solution to those equations because there's one point on the graph where those two lines meet. That point is -4, 1. I love this. Look, both lines have that point. So not only do they cross there, not only do they cross right here, but both of the lines have that point within it. This coordinate point lives on both the black line and the blue line. That means it's a solution to both lines individually. So since it's a solution to both lines individually, it's a solution to the system simultaneously. So now let's look. We looked graphically at two lines. Now let's look algebraically at two lines. Is there an ordered pair that is a solution to both of these linear equations? And I want to see what you guys said. 110 of you said yes. Ideally, the answer would be yes, because that's kind of the lesson we're dealing with here, right? And some of us did say no. But if we connect the algebraic lines, these, to a graphical picture, we know if those lines intersect that there will be a solution. But we don't really know until we know. I, for one, well, maybe in this form I could, but sometimes I can't just glance at this and decide if they're going to have a solution or not. We got to kind of figure it out. And there's two ways to figure it out. One way is to graph it. Here's Here's the example. We're going to graph the system. These are those equations. And in fact, they do cross. They cross right here and 2, 3. So there is a solution. Just like we reviewed in class, when you have 2 or more equations, it's called a system of linear equations. And the solution is that x and y value that makes both of those equations work, that makes both of them true. And graphically, it's where they cross. So I loved your answers to these questions. I already read them. Would you rather have the equations or the graph? And a lot of you said you would rather have the graph because you can just look at it and immediately see. Look, graph, 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 graph. Visually makes it quicker, easier. What else do we have here? Anybody say just equations? Graphs, graphs, graphs. I don't see anybody who would rather have the equations. And I'm with you, honestly. I'm a very visual person, so I agree. These 2 lines represent a system of equations. So this was just an example for you guys to try it. What is the solution to the system? And I actually want to go to your responses on this slide and overlay it. And you can see, ooh, that orange dot just kept blinking. That's because everybody clicked the same dot. And you can see here the summary responses. So many of you, look at this long list, chose -1, 1. Not a single person got it wrong. It looks like some of us wrote it out, but that's okay. This is still correct, but it just didn't read it as correct. You know what I mean? Everybody got it right. That is amazing. That's awesome, you guys. So we're getting to the point that we know that a solution is where those lines intersect. What about this? Does this have a solution? I mean, when you look at this in the viewing window, they don't cross. Let's see what you guys said. A lot of you, 99 of you said yes. 12 of you said no. Ideally, you can tell from the slopes and the way that they're going, they will intersect. They just haven't done it yet. So this, I would argue this is almost a trick question, almost. But it does have a solution. You would just need to find those equations and see where they do intersect. And I love this. Look, here we go. Louise Hay, this mathematician, found those equations to see where they would intersect. And the slope of the line is a big tip-off there. What about this one? Does this have a solution? Now, obviously, looking at these lines, the slopes, those lines have the same slope. They're never going to intersect. So these do not have a solution. And let's see your thinking. Awesome. Most of you said no. And why? Because they're parallel. They'll never cross. Oh, I like this. They're the same lines in different locations. They run parallel to each other. And I like this because it's not necessarily totally correct, but I like where this person was going. They're obviously not the same lines, right? There are 2 different lines. There's 2 different y-intercepts here at 3 and here at -1. But I liked where you were going. They have the same slope. So they're sort of like the same type of line. Awesome. This is so much fun. I love looking back. Hey, look, 2 people are in here right now. I wonder if they're doing this right now. We should send them a message. Or if they just forgot to log out. That's hilarious. So now this was a bit of an extension, kind of taking it a little bit further for you guys. They wanted you to graph 2 lines who has a solution of 1, 4. Now remember what it means to have a solution. It means that line goes through that point. So they wanted you to graph 2 lines that go right through 1, 4. And I loved this screen. Check out the overlay here. Look at all the different lines that you guys graphed. And every single one of them, except for this guy, goes through the point 1, 4. So this is just kind of an outlier, an accidental line there. Everything else is beautiful. You guys did amazing. You can see how many different types of lines you can draw going through that point. As long as it went through the point, that's all that mattered. You can see over here all the different equations that flooded those screens that you guys put in. And all of them, except for just that one little guy, are all correct. They all go through the point 1, 4. That means 1, 4 is a solution. So we kind of worked backwards there. All right, so I hope that this helped a little bit just to kind of see how the Desmos activities work when they're not polygraphs. I know we've done a lot of those polygraph games. And to talk through systems a little bit, we're going to continue on our systems journey when we hit semester 2. And let me show you one thing before we go. This will be the shortest play pause it in history, but don't forget that you guys have your Star 360 assessments next week. Monday's a holiday, Tuesday is your reading assessment, and Wednesday is your math assessment. Just to reiterate, this test does not go in your course grade book. However, I want you guys to do your very, very best. It's a perfect time for you, and I said this about our exam too, but I mean it also with this. You, your learning coach, myself, the school, for us to see where we can help you. What are some areas that you need growth on? And then also, what are some areas that we can celebrate that you're just flying by? This is an adaptive test, so you guys might see some questions we've never covered before. You might even see some geometry and Algebra 2 questions, because as you take the test, the questions will get more challenging because it's trying to see what your math level is and what your reading level is. Some of you might test at a high school level. That's the way that these tests work. It's different from our exam in that way. And also, it's just a totally different test. So don't forget to take it. I don't want you to think if you were exempt from your exam that you're exempt from this. Totally different. Everybody will be taking these Star 360 tests next week. Other than that, that's the only thing you guys have on your plan for math, other than making sure that you're all caught up on everything for the January 22nd end date. So if there's anything you want to retake, anything you have missing, you want to make sure that's in by next Friday, the 22nd. Otherwise, you won't be able to have access to it again. All right, everybody, have a great weekend, and I will be available by email next week, and then I'll see you the following week for semester 2. Bye, guys.